Okay, everybody. So this is our first lecture for week 3. So if I click the home page here on our website, it should look the same for people in section 12106 and 12107. Scrolling down here, you can see that we have links for our Zoom meetings. The first one is right now. Okay. So what we're going to be doing this week is we're going to be continuing on with variables. So I think this lecture here is going to talk about floating point numbers a little bit. And then after that, if we still have time, we'll take a look at some of the Zybook stuff. For lecture 2 this week, we are going to be looking at the exercises in Zybooks, and we're going to talk a lot about the modulo operator, which is a bit tricky for people. And so we want to make sure that we do go over that. And but that will be on Thursday. Now for your work for this week, if you scroll down here, you'll see that I've linked the material from last week down here, and also the new material is below it. So we have the normal stuff. So we have a lab 2, which I need to record a video for you guys. And we have a week 3 reading, and we have a week 3 homework. Okay. The only other announcement I have is just I think I sent this in a separate announcement, but the Computer Science Club is going to be meeting on Tuesdays at 3:30 in B&E 202, so Business and Economics. It says here, but that's from my face-to-face class, which actually does meet in that room. So yeah, if you're interested, then go on by. Yeah. So I think that's all the preliminary stuff here. I will remind you guys, if you didn't see my other announcement about it, maybe I'll click on announcements and I'll look at Canvas grades. So if you look at the announcement, it will tell you that, well, first of all, if you're on the free trial, you'll only have access to chapter 1 and your grades will not transfer to Canvas. Uh, if you have entered a code or if you purchased access, uh, the grades will transfer to Canvas. However, you need to make sure that you at least go from Canvas to Zybooks for every single assignment. So what does that mean? What that means is this. So like, let me go home and we'll scroll down to like the week 3 assignments. Now, week 3 reading and week 3 homework are going to take you to the same place in Zybooks. Chapter 3. Now, but they're two separate assignments here, and you have to click on both. So like if I click week 3 reading like this, and then I load week 3 reading in a new window, it will take me over to Zybooks like this. And you see section 3.1 is part of week 3 reading. But I can go through here to a later section, and down near the bottom, right, I have challenge activities. The challenge activities are part of the week 3 homework. So if I do this, this should affect my homework grade for week 3. However, it won't. It won't actually transfer to Canvas if I do this because I've never clicked on the week 3 homework assignment. So in order to make that work, I have to click back to home, go down here to the week 3 homework, click on that, and navigate to Zybooks that way as well. Now, you don't have to keep doing that. You should just have to do it one time. So now I have come over to Zybooks from the homework and I've gone over to Zybooks from the reading. And as long as I've done that, then my grades will transfer properly for both assignments. Okay. And so that's what the announcement is talking about. So at least one time, you need to click on week 3 reading and week 3 homework and come over here to Zybooks twice, right? Once for the reading, once for the homework. And that should make your grades transfer properly to Zybooks or from Zybooks to Canvas. And so like if I click over here to the thing, this is something that you don't need to do. But if I go to assignments, back, and so like if I click like week 2 homework, for example, and it says 5 students have scores in the Zybook that are out of sync with Canvas, right? And I can try to fix that. by selecting the out of sync users, and I can submit the grades to Canvas, but probably they won't transfer. See, none of them transferred. So there are 5 students that have not navigated to zyBooks from the week 2 assignment, the week 2 homework assignment. So they have to do that in order to get the grades to transfer back to Canvas properly. All right, having said that, that is not what we're trying to do. This is a Discord for a dev site, video game thingy. Let's go back to here and navigate to our class again and get started. So keep that in mind. You do need to navigate to zyBooks from each of the assignments in order to make them transfer. And let's go ahead and get started here. So we're going to do lecture 3, which is on variables part 2. I think we're going to be looking a little bit at floating point numbers. So let's open it up. Here it is. And we will go ahead and get started. Size that a little better. Yeah, so what are we going to look at? We're going to look at the double data type for decimal numbers. We're going to mention scientific notation, how to type it. We're going to talk about constants, and we're going to talk a little bit about the math methods like square root and logarithm and power. And it says integer division and the modulo operator, but actually we're going to do this next time because it takes a while. Okay, so let's go ahead. Yeah. So math operations. So when evaluating mathematical operations in Java, the order of operations is important. Now, don't think too hard about this, okay? The order of operations that's listed here, where parentheses are evaluated first, then it says unary, plus, and minus. I'll show you what that means in a second. Then multiplication, division, and modulo, and then finally addition and subtraction. Now, that probably sounds confusing, but it's just the normal order of operations. Like if I go to Wolfram Alpha, like this, which is kind of a calculator thing, if I were to type in like 2 plus 3 times 5, like that, then the answer is 25, right? Because it would have evaluated the parentheses first, and after it did the parentheses, then it would do the multiplication, right? So the correct answer there is 25. Well, that's why parentheses is listed before multiplication. Now, what about this unary plus minus thing? Well, the unary plus minus thing is for if you do this. Like if I did times like -5, if I tried to type in this, it should group the minus and the 5 together. So the minus and the 5 should be grouped together and then multiplied, and the result should be, as it said here when I typed it, -25. So when it says unary, that means a minus sign attached to a number. So like -5. And then addition and subtraction is last. So like if I put like change that back to 5, like if I do +7, then the 7 would be added last, right? So parentheses first, so 2 plus 3, 5, then times 5, so we have 25, and then add 7, so we get 32, and that's it. Okay, so that is just the basic order of operations that you already know from other math classes and stuff. So Java just works that way. Okay. Now, what about floating point numbers? So floating point numbers are used to represent decimal values. They're called floating point because the decimal point can float. What that basically means is that we're using scientific notation. Okay. Now, the format of a double is 64 bits. Basically, if you think about it this way, like a number in scientific notation is something times something, something times 10 to the something, right? Well, basically, what computers do for floating point numbers is they use scientific notation, and some of the bits, right? Some of the storage space they have for the number goes for storing this first part, and then some of the storage space goes for the second part. It does say here 53 bits reserved for the A here. Um, that's technically including the um, like an implicit um, one there. Like basically the numbers don't add up, right? 11 and 53 is 64, and then one more would be 65. So this should probably say 52 here. It's not important, but this is the scientific notation is how we are storing numbers here. Now, how do we use these numbers? Okay, so you should be used to or getting used to the way that you type variables and assign them values in Java by this point, right? Because we're in week 3. So I'll go over to Eclipse to show you. So I'll go new Java project. Let's call this uh, lecture week 3. Sure, why not? Um, don't check that box, hit finish, expand this, click on SRC, new class. I'll just call it, lecture. That's going to be fine. And I'll check the box for public static void main. Okay, so I've got a blank project here, as we've done many times. This console is left over from a different program that ran. And let's look at it. So we have a blank project, and we know how to declare integers like int, a equals, I'll call it number, int number equals 7, right? For whole numbers, you can use integers, but for decimal numbers, you use doubles. So you just say double, type the word, variable name, whatever you want to call it. So like maybe I'm going to do like, I'm going to call it pi because I'm going to make a variable for pi. What's pi? 3.14. Now that's an approximation, right? Not even a very good approximation, but nevertheless, I can declare a variable. Okay, so declaring doubles is not hard. You can print them out just as easy as you can integers. So if I do system.out.println, and I can say the whole number is, and then I will put the number, right? So the variable name is number, and so I type number here, and that number will be replaced with the 7. Okay, do the same thing. System.out.println, the decimal number is, and I called that one pi, pi, so pi, like so. And if I run this, we should get the whole number is 7, and the decimal number is 3.14, right? So, we can print these out. Everything is fine. Declaring them is just as easy as declaring an integer. So if you only need whole numbers, you use integers. If you need decimal numbers, then you use pi. Or sorry, pi, you use doubles. Here's a little bit of advice for that. So use double when you need to represent decimal values precisely. Use int for whole numbers without any fractions. And then as an example, you would use integer for things that you could count, right? Like number of cookies that I want to eat, which is 7. I want to eat 7 cookies, right? And then you would use double for precise calculations or measurements, right? Like if I was going to weigh the cookies that I want to eat, I would put my 7 cookies on the scale, and I would expect it not to be exactly like, I don't know how much a cookie weighs. Um, I would not expect it to be exactly like, 200 grams. I would expect it to be like, oh, it is 213.74, right? Grams, something like that. And so we would need a double for that, not an int. Int can only store whole numbers. Okay. Now, something that can happen when you're dealing with doubles is that you can have things that are not actually numbers appear. And so there's one thing, infinity, and it represents a value that is larger than any other number. And then there's NaN, which stands for not a number, and that represents for things that are not defined. Now, it says right here what the case is, but we'll just go over to Eclipse and see it. So what happens here, let me change this to like some double. I don't want it to say pi if it's not actually pi anymore. So when you have a double, if you do like a number and you divide it by 0, right? So like 7 divided by 0, what will happen is dividing by 0 will give you infinity. So the decimal number is infinity. So a number, a non-zero number divided by 0 will give you infinity. Now, if you have a negative sign somewhere, like in front of the 7, you can get minus infinity. That's also possible. So you can get a plus infinity or you can get a minus infinity when you do a number that is not 0 and you divide by 0. All right? So that's infinity. Now, the other thing that can happen is not a number. There's various ways to get those. One way is to do something like 0 divided by 0. If you do that, you'll get not a number. There are probably other ways. So like if I were to take like 3 divided by 0, we know that that's infinity, right? We learned that. Let's take these parentheses here. So we have infinity there. What if we try to subtract another infinity? So I put like 2 divided by 0. So what is infinity minus infinity? Well, it is not a number. Like we don't know. So there are different ways to get not a number, but it basically just means it's not defined, right? So infinity is infinitely large. Not a number could be anything. Just it's nothing actually. So number over 0, infinity. 0 over 0, not a number. Okay. Now we're going to see this in a later section. So you don't have to think about it now, really, but I think it's good to see it before you need it. And, maybe you can practice it, maybe in the lab or something just to try it out. So I'll show you what the issue is, and then we'll come back. So let's say I do something like, what's a number here? Like 7 divided by 9, okay? So 7 divided by 9, and let me make them like that. 7 divided by 9, run this, and you get this infinite decimal here, right? And if you look at it, kind of a problem with this is that you don't always want your numbers to look like this. This is probably around 16 decimals of accuracy, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, 16 decimals of accuracy. That's about what you get from a double. Um, So you don't always want them all to appear, right? And some numbers like this are actually displaying 16 spaces of accuracy. But of course, if I change this to like 7 over 10, then it's just going to say 0.7 because that's all it needed was one space for a decimal number. Now, that's not always what you want, right? You don't really always want it so that when you're doing calculations, sometimes it's taking up this much space and sometimes it's taking up this much space, right? And so we want a way to control that. But it turns out that this method here, system.out.println, cannot control the number of decimal places. Okay. So if you want to, you have to do something else. Now, like I said, we don't really need to care too much, but what we can do is we can use this alternate function for printing called printf. Now, printf works very dissimilarly from print and println. And the reason for that is because printf comes from earlier programming languages. Okay, so what that means is that they wanted to maintain compatibility between the printf in Java and the printf that's in C++ and the printf that's in C. Python probably has a printf somewhere. MATLAB has a printf somewhere. Most programming languages have a printf, and the way they work tends to be the same between all the programming languages, with only very minor differences. And so printf does allow you to control the number of decimal places. So I'll show you it, and then we'll come back here. So I'm going to change this print statement here, the print line, just a little bit. So right now it says the decimal number is 0.83333, and then it stops. I'm going to add a little bit of text afterwards. So if I wanted to display text on the right side of the number, the way I would do that is after it prints some double, I would put like a plus again, and then I can do quotes and I can say whatever I want. So that's that. I'm just saying something, okay? Um, so the text in quotes gets printed, the decimal number is, then it prints the number, and then it prints, so that's that. I'll put a space here, otherwise there won't be a space. I'll save that, I'll run it, and let's look at it. So this is how you include a variable in the middle of some text using print line, right? You put the text, end it with a double quote, then you do a plus and you put the variable name, then you do another plus, and you can do whatever you want there. But for example, more text would be enclosed in double quotes, and you get the rest of it. Now, the reason I'm mentioning that is, a text string in quotes, a plus sign, a variable, a plus sign, another text string in quotes. That's just how you use print line to print something like this. Now, if you want to use printf, it's a little bit different. So I'm going to copy all this text here, and I'll start typing a printf, system.out.printf, and then I don't like the way it auto-completed that, and I'll put all that text there right now. Now, of course, semicolon on the end. If I run this, of course, it's going to print out the same thing twice because I just copy pasted this, right? So that makes sense. But what if I want the actual number here, right? Here it's typed out. So what you do when you're using printf is if I want the number to appear right here where the number is currently typed, what you have to do is you include a placeholder for the number. And so the placeholders are going to look something like this for floating point numbers. They are different for integers. So if I want to display a number right where I've got the cursor in the middle of this text, I would put %, a period, the number of decimal places that I want to display. So like if I do 3, that's going to be 3 decimal places, and then an F. So %.3f, that is my placeholder for the number. Now, if I try to run my code now, it will not run because including this placeholder without telling it what to put in place of the number is an error. So if you just do that, it will not run. So what I have to do now is I said the decimal number is %.3f. That's where the number is supposed to be inserted. But what number did I provide this, right? The number is not here. So the number is in this variable sum double. And so the way you do it is after the double quote, you put a comma, and then you put the variable name there. So I called mine sum double. So this number, sum double, is not going to appear at the end, even though we typed it at the end. This variable is going to appear at this location in the text. So when I run it now, you can see the decimal number is 0.833. So that's that. So you can see that the way that you have a number in the middle of the text is different for printline and printf. Okay. Now, the thing about printf or one of the things about printf that's kind of nice is that if I just make a couple of numbers here, I'll do doubles again. X equals, let's say, 2/3. And let's say double Y is, I don't know, 2/5, which is like 0.4, right? So this one is 0. Bunch of sixes, more than that, but that's all I feel like typing. Whereas 2/5 is going to be just 0.4, right? Um, so you can even include multiple numbers in your printf by system.out.printf. Also, we're going to have a little mistake here. I'll fix it in a second. Wait, oh, where am I? So I'll just say X is, and then I'm going to display X. So percent, let's do 2 decimal places. Percent dot to F will display a number. And then I do, and Y is, and let's also do 2 decimal places. Percent dot to F. So now I have two placeholders, percent.2f and percent.2f. So that means I need to give it two variables to put in there, right? I need a number to go in the first placeholder and a number to go in the second placeholder. So the numbers were x and y, so I will just do comma x, comma y. So notice that these are not inside of the quotes. These commas are not optional. We're providing printf with three things: a text string, and the variable x, and the variable y. So three things altogether, three arguments to the function. Okay. Now, if I do this, it will print this out, but it'll actually print it right here, uh, and it'll look ugly. There we go. So it printed the decimal number is 0.83, so that's that. And then it immediately started saying x is 0.00 and y is 0.00. Why? Because I forgot to type these as decimal numbers. And so we did integer arithmetic. And so anything less than 1, the decimal part disappears and you get 0. This will fix it. Yeah, so x is 0.67 and y is 0.4. But you'll notice that it's still being printed on the same at the end of the line here. And that's because printf does not go down to the next line when it's done automatically. So you have to include what we call a new line. So a new line is this, \n, or you can use %n, and that means go down to the next line. So if I want to go down to the next line after the decimal number is %3f, so that's that. Right here, this is where I should type \n. Okay. And now if I do this, it will run correctly. And because of that, you'll see a lot of printf statements ending with \n, just as the last thing there. And that will kind of make it function as a print line. Now you could use the \n actually anywhere in any of the print statements. So like if I come here to this one and I just say the decimal and I put like \n, \n, \n and run this, you'll see that these new lines actually appeared, right? We actually ended this line, so that's a \n, ended the next line, ended the next line. Three lines were ended with the new lines. You can include them in print line, printf, anywhere. If you put a \n, you'll get this kind of thing happening, skipping lines. So just keep that in mind. They're just kind of required for printf. So that's why I mentioning them now. All right. So that's kind of printf, at least printf for displaying doubles. If you want to display an integer, you can. But again, we'll learn this later. I'll just say The number is, and if you're displaying an integer like number, it would not be percent dot 2f anymore or percent dot whatever f. It'd be percent d. Percent d is for integers. And then I can display the number, and also I'll put a backslash in. So you see the number is 7. So you have to be careful because like if I did accidentally type, like I was used to doing dot 2f or something for 2 decimal places, I'm going to get either the wrong thing printed or just an error. In this case, I just got an error. Okay. So you have to use the right placeholder for the type of variable that you have, unfortunately. All right. So that's how printf works. You'll see examples right here in the notes. So like you can see percent dot 3f, that's for 3 decimal places. You'll see percent dot 2f, that was for 2 decimal places. And then the last one is an example of displaying 2 variables, right? X is percent dot 4f, Y is percent dot 4f, and the 2 numbers were X and Y. And the first number goes in the first placeholder, so the X goes in the first placeholder. Y is second, so it goes in the second placeholder. Both of them are to 4 decimal places because that's what I typed, right? I did 4 and 4. So I got 4 and 4. All right. So we can, read more about this. Like it mentions the fact that we have to include the backslash in if we want to go down to the next line. And mentions that these commas here are not optional when you are providing variables to the function printf. All right, decimals. So this is standard for computers. When you're typing in a number in scientific notation, let me just go here. I'm just going to type in scientific notation and hopefully get a summary. So we know that you can type a number like this, 123.1, in scientific notation like this, 1.231 times 10 to the 2, right? And the 2 is because we moved the decimal place 2 places from its original location up here, 1, 2 places, to be in front of the 1, or after the 1. So we moved it 2 places, 1, 2. And so that's why it has to be a 2 there, right? Well, if you wanted to type a number in like this, 1.231 times 10 to the 2, into the computer, you would not type it like this. So the standard thing to use is this E, which I guess stands for engineering notation. So like double Z equals, if I want to type 1.231 times 10 to the 2, that would be 1.231, and you would just say E2. The E is basically the times 10 to the times 10. Okay. That's just the way it works. So 1.231 E2, that's 123.1. And I can show you because I can come up here and I can just say the decimal number is, let's change it to Z. Let's change this one to Z. Run it. And you can see we got 123.1 and 123.1. The second one, notice it's 123.100, and that's because this came from printf. And the printf on this line was .3f, 3 decimal places. So we still got our 3 decimal places here, right? Using printf. Okay, so what was that? How to do scientific notation. You can also use negative numbers there in scientific notation, like 123, like 1.231 e negative 2. And if I do that, then that's moving the decimal place in the opposite direction. I'm not going to teach you about scientific notation here. I'm just explaining that the way you do it is just with this E. Okay. There we go. So like 1E4, that's 1 times 10 to the 4, which is 10,000. 2.3 E negative 5, that's 0.000023 because the decimal place needs to be moved 5 places in the other direction. And that's just how you type scientific notation. Okay. Next is constants. Constants are, as it says here, variables whose values cannot be changed once assigned. And then they give you an example of how to do it here. Now, what you can notice from the example is the way to declare a variable to be constant is just by using this word final in front of everything you were going to write. So if you were going to declare a constant integer, it would just be final int instead of just int. The other thing you can notice here is that the name that we used was like max value, and you'll notice that it's all uppercase, right? And that is just standard for constants to be listed as all uppercase. It's just something that people do. It's not required, it's just something that people do. So if you come here, and I'm going to delete most of this, and I have these numbers here, something that you might do is you might say, oh, I'm going to need the number pi, right? So, or the number e, right? Do you know e from like logarithms and stuff? Number e, right? So maybe you need this number here, right? So you can get it other ways, but I'm going to copy it, come over here, and I can say like final int e equals, I said int, but this must be a double, right? Um, because it's a decimal number. So final double E there, and then I would have it. And then I could use E later on. Or I could do final double pi and then have however many 3.14159, I think 58 or something, but I'll just do this. So I'll do final double pi, right? So if you know that you're never going to change that value, you could declare it as a constant by just adding the word final in front of it. Why? You can make your code a little bit faster that way. And also you can know that the number will never change, so you can rely on it being what it is. Nobody can change it, right? Sometimes you have code that many people are working on, and you want to set these constants and you want to know that for the entire project, they're all going to be the same number. All right, so those are constants. You'll see them in the Zybooks when we look at the Zybooks. Not today, but next time. I have a Zoom thing in the way here. I'm trying to get it out of the way. Okay, where are we? Here. Math functions. All right, math functions. So in Java, all of the math stuff is inside of the math class. If you're looking for documentation, I would recommend that, going back to Safari here, I would recommend that you either use the textbook that I linked in the previous lecture, like the previous week. I should link it everywhere though, so I'll change this. There's a textbook you can use. Also, if you just go to any kind of web browser, like if I just go Google, um, if I just type, what am I typing? Um, Java math. I'll just do Java math. When you do this, you'll find links that look relevant, like Java math class. I'll do the W3 schools one because W3 schools has a lot of good documentation here. So they're going to explain how these things work. So like math.max can be used to find the highest value of X and Y. Math.min can be used to find the lowest value, right? Minimum. Math.sqrt, that's a square root. So this is how you get a square root. ABS is absolute value. POW is power. So if I go here, right, like normally if I want to power, like if I say 3 to the fourth power, 3 to the fourth power is 81. 3 times 3 times 3 times 3 is 81. Okay. Well, how would you do that over here, right? Let's say I want to calculate that. So just get rid of this. Double X equals, well, how would you do it, right? We don't know how to type exponents. So you could do 3 times 3 times 3 times 3. That would work, right? You would get 81 there. So if I do system dot out dot print line and I say result and I put in the X, we should see 81, of course. But that is not um, necessarily the easiest way to do it. So a different way would be with the power function, math.pow 3 comma 4. And maybe I should do 3.0, 4.0 if I'm using doubles here. And so that's going to be 3 to the fourth power using math.pow. So we should also get 81, and we do. Okay. Now what if you want a square root? Well, that would be math.sqrt, and you put in whatever you want. So square root of 64, what's that? I think it's 8, right? Run this, you get 8. So you can put integers in here, you can put doubles in here, and the result will be correct. Well, as correct as it can be, because integers can't have, decimal parts. So math.sqrt, we get a square root. So we got a square root, we've got power. Those are the most common. You can also do logarithms. So like, what is the logarithm? In this case, natural logarithm of 64. It is 4.15. What about log base 10? That's called log 10. You'll get a different number here, 1.8. What about log base 2? They don't have a log 2. Right? Just guessed. I just guessed at what the name was. I could type log. Come on, autocomplete. L-O. So we have log 10, log 1p. What's that? Natural logarithm. Okay. Well, it looks like we got log and log 10. We don't have log base 2. So log is the natural log. And you can put a number in there and you just get an answer. Okay. So we've got exponential as well. That's going to be e to the x. So if I do like e to the 1, I'm just going to get e, that number that we talked about before. I should do 0.0. Oh, right. No, never mind. I was changing this to exponential 1.0. So exponential is e to the x. So this will be e right here. You can change that to e squared. You'll get a bigger number, 7.38. So these kind of math functions that you've seen in math class or physics class or chemistry class, you can access them, but they're all going to start with math dot. Okay. And in fact, if you need pi, before we were doing this, right? You saw me do something like double pi equals, and I wrote like 3.14159 or something, right? Well, you don't want to have to do this. Um, so you can get the actual value of pi, at least as much precision as we can have on our computer, by doing there's a built-in constant for pi. So the built-in constant for pi is math dot capital P capital I. So math dot pi is pi. So I'll just change this here. Forget x up here. I'm going to go down here and I'm going to change the x to math dot pi. Notice the uppercase M on all of the math that I was typing. And I can get 3.14159, 265. So this is pi, but it's in math.pi. So math has these things inside of it, and we can use them. So this example right here was to calculate the area of a circle. So you might remember that the area of a circle, right? So we know that for a circle, the area is pi r squared, right? Pi r squared. So if you wanted to do that in Eclipse, how would you do pi r squared? Well, let's say uh, double radius equals, I'm going to say, 7.0 radius of a circle there, right? And then if I want to calculate the area, it would be pi times r squared, right? But to get the pi, it's math.pi. There's your pi. And they do the radius squared, r squared. Well, radius is what I called it. You could do pow, actually, math.pow. And to do the radius squared, it would be radius and 2, right? So this is pi r squared written in Java. Pi is math.pi. R squared would be math.pow. You put your r here. In my case, I called it radius, and the exponent is 2. So this is pi r squared. Now, this is a lot of typing for the power. So a lot of times I would just do radius times radius. And radius times radius is also radius squared, right? So this would be a correct calculation. So I could do system.out dot print line, and I could say radius in quotes, radius colon space, and let's put the radius, and then area, and let's put the area. Right, so if a circle had radius 7.0, then the area would be 153.93. And but the calculation, right? This is how you'd have to type it to get the correct answer, right? You have to know how to get pi. This is just the same thing, just written slightly differently. And then we get to the modulo operator. So this is where I wanted to stop for today, because the modulo operator has kind of a lot of little tricks to it. So having said that, this week's lab has you do 2 problems. The first problem is basically this almost, where you're calculating the area of a circle. The difference being that I just typed in the radius here, 7.0, but you're going to have the radius being read in from the user. And so that'll be all done in the video, but like you can imagine that what it would look like is I would declare a double for the radius, and I would declare a double for the area. But then in order to get the radius from the user, you're going to have to use the scanner. So we didn't really use scanner today, but to use scanner, you'd have to have import java.util.scanner up top. That's necessary. You would have to have scanner SCNR equals new scanner system.in. Here, you would have to tell the user what they're supposed to be doing. So like you'd say like type in the radius of a circle, something like that. Tell the user to type something. Then you'd have to read in the radius with radius equals SCNR dot next capital D double parentheses semicolon. So you have to get the radius from the user. After you get the radius from the user, then you can calculate the area the same way as before, and you could print it out. So there will be a video for that lab, but essentially I just did the lab for problem one. I'll run this. It says type in the radius of a circle. I could say like 3, and then it says radius 3, area 28.27. So, you're going to have to use the scanner, which you use all the time in Zybooks, in order to do this lab. I'll record a video for that, though, and post it for you. That's more thorough than what I just did. Now, anyway, that's going to be it for today's lecture. There'll be a lecture on Thursday that will cover the modulo operator. And we do need it because if I go over to the week 3 reading or the week 3 homework, you'll see that what we were just talking about was kind of floating point numbers, just as kind of variables. But if you actually look in the week 3, we have a lot of, it says like arithmetic expressions for integers here. And this is going to be, how to do addition and multiplication and all this kind of stuff that we didn't really spend very much time on yet. And so I want to make sure that we do some of it. Although I don't see a lot of modulo there, so maybe it's in week 4. Yeah, it's actually there. So we were kind of doing some of this stuff from week 4 already. So maybe we won't do modulo next time. Maybe we will just do Zybooks stuff. All right. Well, anyway, that's going to be it for now. I will talk to you guys later. How do I shut this off? I never know. End.